All right. So in this session, we will see about why tracing is important in a distributed system. And before we get into the details, let me first introduce myself. And I'm Raja, working at Palo as a tech lead. And another fact that you may not know about me is I'm also a contributor and a committer of Zipkin, which is a leader in distributed tracing at the moment, like we can say. And I started using this project couple of years ago and started contributing it back, and then it became a passion for me as well. So we will see a little bit about what is observability and how tracing fits into the observability stack, and why it is important in a distributed system that spans across hundreds of services. In this session, the main takeaways are you'll be knowing about what is distributed tracing and how you can use Zipkin instrumentation libraries to instrument your code, and who is using Zipkin and how are they using it. So that you'll get to know about some case studies, about real case studies from production environments from different sites like Netflix, Twitter, etc. And this is one of the cool term. Everybody wants to know what is the observability, and there is no clear definition, just like microservices. But there are certain attributes that we can define to call whether a system is observable or not. It is borrowed from the control theory from mathematics, that a system is observable when if we can predict the state of the system by having data points from the past, the present, and the future. So if you have the data collected from these three things, we will be able to observe the system in a better way. And if you think about in the service or in computer science, if the system is observable, if we know about the data that we collected in the past and we compare it with the present data, and if we can predict to a certain extent how this service is going to behave in the future, then the system is called observable. There's the next question that always comes to everybody's mind is, what is monitoring then? Monitoring is overall report of the system. It mainly talks about what is the current state of the system, and it cannot give you data points or control over how the system is going to behave in the future and whether you can predict the behavior of the system or not. And next thing is a very common thing. There are people typically call three ways of observability, and we have logs, and we have metrics, and we have tracing. How all these are different, or all this same, or this is an extension of all this? We will get to know about it in the next slide. So logging is more about talking about a collection of events or a set of events. So let's say you have a service and you're trying to make a payment, and you will get to see a different log statements in your log aggregator or something, right? So when you see log statements, what you can see? You can see the timing, what time the event has occurred, and other metadata and data that enriches that event, that particular event. Metrics is collection of these events. So let's say there are like 100 payments happened over the last 1 minute, or 1 million payment happened in the last month, and how many payments got failed. So it's a collection of aggregatable data, that is the metrics. And tracing is per request curved. For example, you're trying to make a payment, and that payment has to go through multiple services in a distributed system. It's not just going to do front end, back end, and database. It's going to traverse through multiple different services. And when that happens, for this particular user, for this particular payment, what are all the different paths this request has taken through. That is what you will get to know about from distributed tracing. And this is actually, this term is coined by Peter, who wrote an amazing blog post about it, and which I have given in the reference, which you can look at later. And let's look at a hypothetical request, right? So typically in a distributed system, you'll be having a gateway, and you'll be having different services if you're trying to make a payment. And as an engineer, whether you are developing the services or whether you are responsible for operating these services, what are all the different things that is important to you? First is, if there is a request, what are all the different touch points this request is traversing through? Which path the request is taking in a system of 50 services or 100 services? And what services are my customers? So for example, if you're working in a team, you may not be responsible for all the services. You'll be responsible for only a subset of these services. So when you are responsible for only a subset of services, you must understand who are all your customers. For example, I'm responsible for let's say the payment service. So who is my customer? The main customer is the biller service. And next, I should also know about who are all my who am I calling to, whom I depend on. Billing service is typically depend on the payment service, the user service, and third-party biller gateways. So these are the three different services that I'm depend on, which I'm not directly responsible for. Okay, so let's say there is a bill payment request which got failed in the user service when it is trying to update the user balance in the wallet or something. So how does my service react to it? Am I doing retries? Am I trying to do some compensating transaction? How much time does it take for this request? How do I know this data and when something goes wrong? So, and also if you're, let's say if you're a service which is used by multiple different services, and you must also know who is blocking you the most. For example, in this use case, let's say there is a biller service. Hypothetically, there is some other gateways that are calling the biller service, and you say you can think of like the mobile gateway is pretty much fast, but my web gateway or POS systems are pretty much slower and blocking my request most of the time. So you must know which service or which systems are blocking you most of the time. So why do we need all this data? Why do we need more information around this? Because when you operate your services, it helps you to narrow down the issues quickly when something goes wrong. So and also the turnaround time and response time to issues, we can shorten it, and also it gives you an opportunity to understand your system better, and also helps you to optimize your services. And so it summarizes basically what I said now. So you can find the latency. For example, typically a payment request or an authentication request takes about let's say 15 minutes or 15 seconds or 10 seconds. So out of these 10 seconds, which service consumes the most? And for example, in a typical complex applications, it's not straightforward to understand where the request traverses through, because it will be spread across multiple teams, sometimes across multiple geographic locations. The teams may not be co-located in the same office or in the same geographic location. The teams who are responsible for different services will be located in different places and can be written in different languages. And so how do you understand who are all your customers in the sense the service customers? Who is calling you? Who are you calling on? Who are you depending on? So if something goes wrong, how do you contact the person on call for this service? So these are all some of the things we can understand from the tracing. And also, in a complex environment, you may not get a full picture of your architecture. And sometimes what happens is architects will come up with a system design, but the end product might be totally different, because systems keeps evolving, and sometimes these artifacts produced by architects may not be up to date. And how do you know that whether the system architecture is conformant to the design that is produced earlier? So we can use this to tracing to make sure it is conformant to the designs. And also, when something wrong happens, we can also save these traces and share these traces with the different teams. Sometimes these teams can be internal teams, sometimes it can be an external team. Let's say you're liaising with different third-party APIs, and most of the time your third-party APIs are blocking you and making you not to meet your SLAs and SLOs of your services. So how do you know that, how do you share these findings to your third-party vendors or third-party APIs? So we can save these traces and share with them and show them, because of this, your API is taking this much time, and because of it, we're not able to meet the SLA of our service. So we can share traces with them and help them to mitigate the problems. And when it comes to tracing, there are a lot of tracing jargons that is around there. And the main, I have listed down the main important jargons here. First is the span. Span is the basic unit of work, which means span actually comprises the smallest unit of work, and it can be stopped and started, and it records the timing data of that unit of work. And trace is a collection of spans. It can be a single span, it can be multiple spans, and it can be in one service, it can be in multiple services. And tracer, tracer actually adds metadata about your operation and adds annotations and tags to it, and etc. And instrumentation typically happens within your services, and where you have to record your timing data, and it has nothing to do with the tracer, because the tracer will happen outside it. And then you'll have a collector. So you collect these spans, you collect all this timing data, and where do you send it? You collect it from hundreds of services spanning across thousands of instances. You have to send it to somewhere, right? So yeah, the collector is a place where you send these spans, and collector collects these spans and saves in the one of the storage mechanism the collector is configured to. And you'll have tags and annotations, which enriches data about your infrastructure. For instance, which data center this service is located, which Kubernetes pod it is located from, and which availability zone it is from. So this kind of metadata you can enrich to a request. And to put into a little bit of perspective, this whole thing is called a trace, and this small unit is called a span. And these are the different services this hypothetical request goes through, and these are the different span names. You can give a name for your span. And so typically you'll have a tree-like structure, where you'll have a treed structure of traces where you can expand and collapse and view it to understand the latency. So let's see how Zipkin fits into the distributed tracing now. So to give a little bit of history about Zipkin, Zipkin originally originated from Twitter engineering. It was used by their performance teams, where they felt a need for having a tool like Zipkin to understand more about their system and more about the latency, etc. And then they actually contributed and made it open source 4 years ago, approximately. We are going to have the 4th year anniversary in a couple of days now. So once Twitter donated this, people around the world who are operating distributed systems started to see a value for it. And Zipkin is actually based on a paper called Dapper, which was originally published by Google. And Google came up with this paper some years ago. And after that, most of the tracing system right now are using the mechanism which is based on the Dapper paper. And we are not seeing there is no real alternative to the Dapper mechanism at the moment, which is in production. But it is fairly effective so far. So to get back to what Zipkin is a collection of libraries. It's not just one library, and it has two parts. One is your instrumentation libraries, where you can use to instrument your code of different languages, and the other part is your collectors, where it can receive these spans and collect it, process it, and store it. So it's two parts. So what Zipkin is made of? It has a very long history. So initially, when Twitter made it, Zipkin was developed using Scala, and then the last couple of years, Zipkin was using Spring Boot with Undertow, and in the last 6 months, it is changed to Armeria with Netty, and it's basically a Spring Boot service which collects the spans and processes it. And it is mostly written in Java and a little bit of Kotlin for instrument integration tests and of that sorts. And so for instrumentation, Zipkin has one of the main instrumentation library, which is called Brave. And Brave has instrumentation for most of the popular Java frameworks like Spring. And some of you here might have used Spring Cloud Sleuth, right? Yeah, so Spring Cloud Sleuth is a wrapper around the Brave instrumentation so that it can auto-instrument your requests in a Spring Boot application. And also it has, Brave has other instrumentations for Netty, OK HTTP. We can also instrument the database calls, etc. And also it supports wide variety of languages. It's not just about Java or JVM languages. You can instrument your JavaScript, Node.js services. We have instrumentation for Axios and a lot of other JavaScript libraries as well. Have instrumentation for Golang, PHP, Ruby, and even C#, which I did not mention here, C++, etc. And I spoke a little bit about Spring Cloud Sleuth, so I'm going to skip it. And so Spring Cloud Sleuth, you can auto-instrument the code, and also what you can do is, for example, there are two types of instrumentations you can do. One is in-process instrumentation, which is if you have a request, and you can time the request coming into your service and the time it leaves your service. Or what you can do is, you can also split it into multiple smaller pieces of spans, because that specific request can do a multiple unit of work inside the same service. For example, it can do some data massaging or something. It can do some data transformation inside the same service before persisting on your data store. So how do you measure the data transformation time taken? So you can actually, what you can do is you can create a new span with annotation if you're using Spring Cloud Sleuth, and create a new span out of the request easily. And that is one way. Or Or what you can do is you can also start a span using these span dot start scoped span, and then you can stop it, which is another simplest way if you're using Java. But there are examples out there in the Zipkin GitHub pages about how we can instrument for different languages and different libraries as well. So the next important question that comes to the mind is, all right, I want to use Zipkin, and I'm going to instrument my code, and how do I transport these spans, which is all these services are located in different cloud providers or in different places. So there are different transport mechanisms we can employ. One is the most obvious one, the HTTP as one of the transport layer. We can use that. It'll be so what we have to do is we have to specify the Zipkin endpoint in your client services, which can post these spans in a different thread, and that is one option. And another option is using the messaging like Kafka or RabbitMQ. That is another option, but we have to think about adding that dependency for each and every services that you have. So that is one drawback of doing that. And another option is using managed services like Kinesis or SQS or Google PubSub. And we'll see about some of the case studies how I have used in the past and how some other people are using it. And for storing the traces, there are different options you have. You have Elasticsearch, you have Cassandra, you have MySQL, which is not ready for production because it doesn't scale for the amount of traces a typical production site handles. And we have in-memory, it's just for demo purposes, so it should not be used in production. And there are some community supported versions of VaultDB, and we can also use Google Stack Driver as one of the storage mechanism as well. So how do I set up Zipkin for production? So the simplest way is to start identifying the teams which are ready, and also it's sometimes it works better if you can start instrumenting the newer services instead of existing services, so it will be easier to get a start of it. And one of the famous question that always keeps popping up in the support channels, I forgot to mention that Zipkin is mainly run by volunteers, and so we always get support questions about which storage that we need to use. The two most popular thing is either Elasticsearch or Cassandra at the moment, which is supported. So in order to choose between these two, it's more about which your engineering team is more comfortable with. There is a lot of pros and cons in using both, but it always boils down to what you're most comfortable with, and there is no real comparison between these two when it comes to the Zipkin storage. And which transport layer to choose? In my experience and opinion, I would suggest to start with the HTTP as a transport mechanism, because it's simpler and easier to get started with. And if you're not able to meet the demand of your services, you can always switch back to some of the messaging middlewares like RabbitMQ or Kafka. And also one more thing that you may have to think about is budgets. For example, how much storage that you're going to allocate for your tracing, and how many services are going to use it, and how much sampling percentage you're going to use. These are some of the things that you may have to think about before you set up the site for tracing. And we'll look about some of the case studies, and I'll skip through quickly. And so it originated at Twitter, so I'll go with the Twitter example first. So this came, actually I luckily I got a screenshot of this from the Twitter presentation at Scala Days. So they are using Zipkin now in variety of systems. But one information that we have is they are right now using it for their distributed build automation. So they have a very big Scala, it's a big Scala base, and their build is not happening at one system, it's happening in a distributed system in different places. So they use Zipkin to monitor how much time it takes and which build system is taking so much time, and analyze that using Zipkin. And they also use it in wide variety of other services as well at Twitter. And next one is Netflix. So Netflix had their own tracing system before they started using Zipkin, and right now most of their services they migrated to Spring Boot and Java, and they use Zipkin to understand the latency and enrich the services with a lot of metadata about how much time it takes for caching and those kind of things. We will see about an example trace from Netflix in a little bit. And they also have Netflix also have a custom visualizer for tracing. So they use Zipkin UI for some items, but for some items they have a different UI which is internal to them. And they are a very big Zipkin shop, to be honest. And next thing is Ascend. Ascend is my previous company, which is a regional fintech company operating at 6 countries in the ASEAN region, and we have around 300 services and spanning across data centers at 6 different countries, and operating at AWS and Google Cloud. And we started the instrumentation at Thailand first, and spread across to Vietnam and Cambodia, and other countries were in pipeline at the time I left. And so at Ascend we use Zipkin to measure the latency of consumer payments from POS systems, from mobile payments, etc., and also P2P transfers, etc. And also, since we have we had around 200 plus services operated by teams across 6 different countries, so we need to know whether they are conformant to the design, architecture design, and who is calling what, and understand better about our own system. So we use Zipkin for that. And this is a typical setup at Ascend. So we wrote a custom proxy at AWS and for GCP. So all the services will send their spans to the custom proxy, which will in turn put it into AWS Kinesis. And then we had a Zipkin server which listens to the Kinesis collector and saves it in the Elasticsearch. We collected around 3 to 4 gigabytes of traces every day, and some sites even collect around several 100 gigabytes of trace data every day, some sites. And next one is Line Carp. How many of you use Line Chat? You used Line Chat? It's pretty big in China, in Thailand, in Korea, and Japan. And they use Zipkin a lot, and they also donated the newer Zipkin UI to the community. And so they process around 50 million metrics a day, and they process around several gigabytes of tracing data, and they primarily use Spring Boot, Armenia server, and Java based. And the next one is a very interesting one. So Zipkin is not only happening inside the earth. So actually Zipkin is used in space as well. So Interstellar is a satellite base station and communication provider. So they use Zipkin to analyze the latency between the satellite communication to the ground station. So not all companies wants to want to set up an infrastructure for satellite operation. So they actually go and take some they take the services of InfoStella, which is called Stella Station now. So Stella Station uses Zipkin to understand what is the latency between different satellites, between the ground station and the base station, and the satellite. And the next one is SoundCloud. I think some of you might have used SoundCloud. SoundCloud is a sound. We can upload a lot of audios and podcast to it, and they have 100 million tracks, and they have 12 hours of audio gets uploaded every minute, and they have hundreds of engineers. They are one of the early users of Zipkin, and they use it in their Kubernetes pods, and they also enrich their services with a reverse lookup into the Kubernetes pods to enrich back the trace data, which we'll look in a few minutes. So in a typical enormous system, the service graph will look like this. So it'll be a nightmare for engineers who are operating to understand where is the service going and how it is, which service it get failed, and how to debug, and what are all the different data points they need. So service graph helps engineers to understand their system better, and how the overall system is connected with the different pieces. So actually distributed tracing and observability is still in the early stages, and still there is a lot of scope for improvement. And one important thing that people keep talking about is adaptive alerting. So you get a lot of these spans, and how do you improvise from that? You need alerting you need to create models, and you need to compare these models and create alerting around it. That is one of the biggest thing that we have to watch out for. And anomaly detection, when something wrong happens, and how do we know that there is an anomaly for this. And one story that was shared by Expedia, they also use Zipkin a lot. So for example, they had a customer who booked a flight from US to a city in Africa, with a connecting flight in Paris. So what happened? The flight provider changed the flight to a different time and different date. So what happened for this person? The flight has been changed to a different airport inside the Paris. But for her to get through the immigration in the different airport and have a connecting flight to a different airport in the same city is a nightmare. So they got these anomalies identified from Zipkin. If there is something changed in the flight booking or anything, how it is going to affect, what are all the different anomalies that we can look out for. So they used their systems in addition to Zipkin to identify these kind of anomalies. And next one is graph visualization. So the UI and UX of distributed tracing is still evolving, and still it is taking baby steps, and it requires a lot of effort from different companies to come up with a better visualization techniques. And also right now, if you look at the UI of any distributed tracing, you have to query for it, and it cannot suggest you navigation and what interests you the most. For example, you could have like 200 services or even 1,000 services in your system, but out of those 200 services, only 5 services interest you the most. So how do you cater for this specific person, and how do you suggest navigation for this person? So those are some of the things which is lagging. And final thing is Vikram was talking about is about the uniform format. So there is no uniform format. There are several efforts that has been there. One is Zipkin's B3 format, and we have open tracing as an adapter for it. And there is a format from Open Census from Google, and which is still in the works. And there is a tracing group in the W3C consortium, and they also have some mechanism of propagating the traces and how we propagate the headers and etc. But there is no proper unified format available at the moment. And I'll skip this, but you can read about it. This is from Adrian. Here I asked him about what to look out for in observability and tracing in the next few years. And I can share the slide, you can read through it. And he's a very nice person. If you want to chat about tracing, you can ping him on Gitter. And also I'll see if I can bring him here for a workshop sometime in this next 2 months. And to give a little bit of demo, actually I did not set up so I did not set up the complete end-to-end service, but I can show a little bit. So actually Zipkin has two different UIs. This is the old UI from Twitter, and which is still used by a lot of companies in the production. So you can search through different services and different spawns, and you can search through different lookup time. And so if you click on a trace, you'll get to see a trace view where you can see what are all the different services which is called for this request, and how much time it taken by it. So it can enrich with a lot of metadata. What is the HTTP method and path and other metadata that we can use. And also it will be it is helpful if if something goes wrong. For example, if you look at this specific trace, this service was keep on trying for a lot of retries, which kept on failing. So the overall time taken is around 60 seconds, and out of which how many seconds is consumed by taken by each and every service. And you can find out this kind of information when you instrument your code. And what I can do is I can show you sample trace from Samsung. So Samsung is one of the adapters and users of Zipkin for their IoT product called Smart Things. So Samsung Smart Things that you connect at your home actually uses Zipkin to analyze the communication between the devices to the service, and how devices authenticate with each other, and how long those devices takes for the authentication, and how these devices sense information. All these are instrumented by Zipkin at Smart Things. And you'll see how this typical example trace talks about different unit of work that is done for authenticating the devices in a home, basically. And for example, they use this to debug. If, for example, you have Samsung IoT devices for power and other devices like your smart fridge, refrigerator, etc. If something is not communicating back to the Smart Things server, they use Zipkin to debug that particular device for that particular user in that particular home. So they attach the debug traces, debug flag to send those requests back to the server and see what is wrong with the that particular device. So and also they also use it to blacklist some of the devices if something is wrong, because some devices are not legit devices. and also they identify these kind of things using Zipkin. And also to give a bit of insight, they use Cassandra as their storage, and they are primarily deployed on AWS in the US. And let's actually the typical traces for IoT devices are pretty long, because if you look at it, this one spans across multiple devices and multiple services. It's quite long actually. So when something wrong happens for this kind of request, it's very hard to debug with the traditional tools, and this is where Zipkin comes into a handy alternative for debugging. And we'll see example from Netflix. So this one is a trace shared by Netflix, and they actually showed about how do they use the caching. For example, so they use it to understand which cache it is going through and what is the time taken to read from the cache or from the actual service. So whether the request is going through the cache or whether the service request went to the actual request, actual data store. So these kind of things they try to understand from Zipkin. And this is one example, but they are using it for many different use cases. And this one is from my previous company. We used it for different services, but this one is about some content service, and it typically tells us the request comes to the mobile gateway and go to the authentication service, and then go to the content service, and also it pass through the Hystrix circuit breaker. So we can, when we instrument these kind of things, it will be easier for us to identify for this particular request where it goes wrong. And we also enrich some of the information like which zone the service is deployed in. For example, there are different service zones, availability zones in AWS. So we also enrich our services with some of this metadata to understand better which availability zone this request has gone through. Yeah, well, questions?
How do you trace for drop connections?
Drop connections, right?
Maybe it's an incoming connection request, or it could be data being sent that's dropped.
All right.
How do you trace for that?
So typically, if the service is still alive, it can retry for the sending the spans back to the collector, and also we have a typical request about missing spans. For example, you have a request that has like 10 spans. Usually it will have 10 spans, but one span is missing for this specific request. So we typically treat that as a missing span, and you can identify it by comparing with the other traces. So that's where this tool comes into handy. So you can save your traces, old traces, and you can compare it with the problematic one and see what is wrong, and so that you can identify why something has dropped and how my system behaving when something is dropped. Any other questions?
The diagram which you were showing was the collector or just the event of tracing? Netflix or something?
That is a visualizer, which actually is I said about two parts, right? One is the collector, one is the instrumentation. So you can instrument your services using the instrumentation libraries, and that will send the spans over the network using HTTP or any other transport layer, and it will send to the collector. The collector typically collects these spans and then process it and stores in a database. And we can use this tool, Zipkin UI, to visualize these, to connect different spans and identify how all these spans are connected using something called trace ID. A trace ID is a unique identifier, typically of 32-bit or 64-bit. Sorry, 64-bit or 128-bit, and some companies use 64-bit, but if you have a lot of instances, for example, Netflix, they ran out of the allocation for 64-bit, so they typically use 128-bit trace IDs. So depends on your services. You'll have a trace ID which glues together different spans, which you can visualize in this tool. Does that answer your question? All right. Anything else?
Just one question. So, can I say that this distributed tracing have one life cycle, that it starts from somewhere and it ends somewhere,
Yes.
and it's unique as per that journey?
Yes. So yeah, unlike logging or metrics, tracing is request scoped. So it is very unique for that specific request. So that's why the trace ID comes into picture, which acts as the unique identifier. And the trace, for the trace to start, it has to start somewhere. Usually it will be on the API gateways, which is a starting point, which will generate the trace ID and attaches to the header, which will be propagated to the downstream services, and the end will be the final service, which actually completes the request and sends back to the client, the original call initiator. That's where the the trace gets in. And format, there is no specific format that has been agreed, but universally most of the companies are using Zipkin's B3 format at the moment.
And this trace ID, can we call it as trace ID, or sometimes
Yes.
I read correlation ID?
It's actually same. Actually,
What's the same?
it's the same. So if the teams are using Spring Cloud or Sleuth, we can also print this trace ID / correlation ID in the log statement, so that you can grab the logs better and easier. Anything else? So to close off, actually, Zipkin is very welcoming for volunteers, and if you want to contribute to open source, and if you don't know where to begin, and Zipkin is a very good place to start that journey. And if you want to know more about it, you can reach out to me. I can help you to get started. All right, I have provided some references, and there are also some cool visualizations that is used by Netflix for demo purposes, where you can visualize your services using Neo4j, which they use, I guess. There are a lot of other ways of visualizing their traces and service dependencies, which are still in prototyping at the moment. And I'll be very happy to catch up if you are keen on exploring about observability and tracing in particular. And thank you so much for listening patiently. Appreciate it.